Well, we've solved homogeneous linear systems of differential equations. And now we're going to embark on solving non-homogeneous linear systems. And we're going to use two methods. Undetermined coefficients, which sounds familiar. We've done that before. And also variation of parameters. We've done that before. But now we're going to apply it to non-homogeneous systems. So what we've got here, what we're looking for is the general solution. We want x equals the complementary function plus the particular function. Now, this complementary function is found by solving the homogeneous associated system. So here is a non-homogeneous system. When we take off this part right here, we've got the homogeneous system, which is what we solved before. So putting all this in matrix form looks like this. Now, I want to solve in both of these methods, the undetermined coefficient and the variation of parameters, the first thing we're going to do is find the complementary function. In other words, I'm going to solve the homogeneous differential equation. So I'm going to solve this part, and you know the first thing we do is find the eigenvalues and the associated eigenvectors. And in fact, in the past video, I've already solved that, and we found that the complementary function is this. Now we're going to set that solution aside, this complementary function, and focus on finding the particular solution right here, the x sub p. And we're going to use, first of all, the method of undetermined coefficients. And recall that back when we had, a differential equation, something like this, the first thing we do is speculate what the solution might look like. And since we have a constant over here, we said, well, I think the solution is going to be a constant. Now, if we didn't have a constant, if we had something like 5t plus 4, we would speculate that the solution might be at plus b. And then we would take that and plug it back into our differential equation and see if we could solve for those a and that b. Well, that's what we did with undetermined coefficients. We're going to do the same thing here, except we're thinking about vectors, matrices, instead of just numbers. So what I notice about this differential equation is this part over here is it's a column of constants. So I'm going to speculate that my particular solution is a column of constants. That's what I'm going to do. And then I'm going to take that and plug it back into the differential equation. Okay, so I had x prime equals ax plus f of t, and notice the derivative of this column of constants is a column of zeros, and then I just plug in here. I just plug in, solve this system of equations. Now, of course, what I'm doing is I'm taking this column times this, or this row times this column, this row times this column, and get 4a minus 3b equals 6. And then I take 6a minus 7b equals 4. And the reason, it started off being 4a minus 3b minus 6 equals 0. But I just went ahead and moved the 6 to the other side. Because, 4a minus 3b minus 6 equals 0. Okay. Now, when you solve that system, you get this. That means that the particular solution is this, 3, 2. And if you want the general solution, you just plug back in here. This right here is x sub c, and this is x sub p. There you go. Now, let's look at another one. Let's suppose we've got this one here. Now, and this is already in matrix form. Now, what I want to do is I want to break this thing apart a little bit. I want to write this as 4 over 5t plus 0 over 2. Now remember, this is not a fraction here. This is just this added will give you this exactly. These are little column vectors, matrices. So I'm going to speculate that my particular solution is a2 b2 times t, see, like that, plus a1 b1. I'll just call it that. Now, the derivative of this, of course, is a2 over b2. And what we want to do is we want to plug that back into the differential equation. Remember, we had our differential equation, and this over here is f of t. So we want to plug back in. And when I plug back in, what I want to do is multiply. I want to multiply and gather all my like terms together. But look at this. I'm going to take this first row and multiply it by this column vector right here. Okay. Now you want to be sure you understand what's going on here. I'm going to take this 4 and multiply it by a2t. There's 4a2t right there. See? I went ahead and factored out the t. Plus 4a1. I put that right here. See? Plus 4a1. Okay? Then I take this negative 3 and multiply. I send the negative 3 through. So in other words, I got 4 times this this first position, now negative 3 times this, and notice I got negative 3 times b2 t, negative 3 times b1, see, that right there. And now I also bring in the 4t right there, and that's it. Okay, so that's when I took row 1 by this column. The next thing I do, I'm down here on the second row. Okay, so I take 6 times a2 t, there it goes. 6 times a1, there it goes. Now I've also got 4t. I mean 5t, I'm sorry, 5t right there. And 2 right there, see? Now I want to take 7, negative 7 times b2 t, negative 7 times b1, there it goes. So in other words, I just multiplied through and gathered all my terms together, and I get this, okay? Row times column, and this is one big column right here, okay? Row times column, and then you add these together. Anyway, you want to be sure you know how to get all of this. Now, I've got a system here, and what I want to do is I bring over the A2 and the B2. See? So there's the A2 and there's the B2, and I've just got zeros over here. Okay? So now look what I've got. I've got 4a2 minus 3b2 plus 4 equals 0. See? I'm equating the coefficients. There's no 0t over there, so I'm equating coefficients. Okay? I've got 6a minus 7b plus 5 equals 0. And then over here, all of these equal 0 as well. Okay? So, let's look at this first set right here. I'm just equating coefficients here. Solving this system will give me A2 is negative 13 tenths and B2 is negative 5 tenths. I mean negative 2 fifths. I'm sorry about that. Negative 2 fifths. So I've got A2 and B2. Now I come over here to solve these ones. And in place of A2 right here, I put negative 13 tenths. So now I've got 4a1 minus 3b1 plus 13 tenths equals 0. I just took this and put it right here in place of A2. Now, likewise, in place of negative B2, I'm going to put negative 2/5. Or actually, in place of B2, I'm going to put negative 2/5, and I get this thing. And notice I went ahead and brought the 2 over. Now, when I solve that, I get A1 is negative 19/100ths, and B1 is equal to 9/50ths. So my particular solution is this. My general solution is this. So just a lot of algebra, pretty simple algebra. Where you have to be careful is this multiplying here, because it can be confusing. But remember, this is just one column here. So row 1 by this column, and then row 2 by this column, and then add all of these in. Okay, so now the next method that we want to look at is the variation of parameters. And the variation of parameters, once again, you're thinking about, okay, I've got this homogeneous system. Here's a non-homogeneous system, and you consider the homogeneous system. Now, you want to suppose that, let's suppose that x1 and x2 is a fundamental set of solutions for this homogeneous system on some interval. Okay. Therefore, the general solution for that homogeneous system is this. Now, recall back when we were using variation of parameters, when we had a general solution from the homogeneous, like this, like if we said, okay, C1 x1 plus C2 x2, what we would do with the variation of parameters, we said, well, let's assume there's a function of t here in place of C1. And let's see if we can find out what that function would be. Let's see if we can find the U1 and the U2. So we always start off with this solution for the homogeneous case, and then we set out to find the U1 and the U2. Well, we want to do that here as well. So let's suppose that we've got this this fundamental set of solutions. Here's one right here, and here's another. And let's combine those. Okay, so let's just add those, and we find that it equals this. You can check that out. It's pretty straightforward. Multiplying these out, and you find out, yeah, I can separate it this way. So what we have is this x equals what I'm going to call phi of t, this right here, times this. Okay, so this is what I have. And I have phi as x1, this matrix right here. And I'm going to call that, it's not just me calling it that, it's generally called the fundamental matrix. Okay, so let's take this fundamental matrix, and let's go back and take the derivative and plug it in. Let's just plug it in this right here. So in other words, I've got phi prime of t equals a phi of t. Okay, so let's just plug into that. Okay. Now, consider the non-homogeneous system, this right here. Okay. And let's speculate that there is a solution. This particular solution is phi of t times this capital U of t, which is like this. Okay, so we have a function of t in there and a function of t there, and we're just saying, okay, this phi of t times this thing is going to give us the solution. And we just want to say, okay, if that's the case, if we're speculating that that's the solution, then all we have to do is find this u. We have to find this. We have to figure out what it is. And of course, you recall from variation of parameters, we've got this. Remember how it works. So our job is to find the U1 and the U2. So that's what we need to do here. Okay. Now, let's just look at this and let's see if we can plug back in. Let's see if we can plug in here. So notice the derivative of x sub p, just using the product rule, gives us this. Okay? So I'm going to take this and plug it in right here. And there you have it. And then I'm going to take this and plug it in over here in place of x, right there. And then I've got f of t here. So all I've done is I've just said, okay, let's speculate that this is the form of the particular solution, and then let's plug in and see if we can solve for this u, this capital U. Okay, now, if I do that, let's see what I've got here and see if we can make some substitutions. Now, remember, phi prime of t equals a phi of t. Now, dig this. Here is phi prime of t. Why don't I take this and make this substitution? See? This equals this. So let me just, in place of this right here, put a phi of t. Yeah, like that. So here's a phi of t, u of t. So here's what I've got on this side. And of course, nothing has changed on the other side. But dig this. This and this get rid of each other. So now I've just got this equals this. Now, I'm going to apply the inverse of phi of t to both sides. See? Here's the inverse of phi of t. I apply it to this side over here and this side over here. And now I just get u prime of t equals phi inverse of t f of t. Well, I don't want the u prime, I want the u, so I'm going to integrate. Ah, now we see how we can find the u of t. Okay, so here's what we've got. Okay, now remember, and by the way, this is this right here should be phi of t. Phi of t. Okay, so this is what our solution, our particular solution, is going to look like. Remember, we said phi of t times u of t. So this is what our solution is going to look like, and you can see the problem is just going to be us being able to integrate. So let's look at an example. Let's suppose we've got this system of differential equations. We go through and we find the complementary function, okay? And we've got these two, okay? So we've got x1 and x2. From that, I want to put together this phi of t, this fundamental matrix. And here it is, the fundamental matrix. I just added these two together. This is my fundamental matrix. Now, what I'm going to need to do, I'm going to need to find the inverse of that. Because remember, what we want to do is we want to integrate the inverse of that times the f of t. So let's see if we can remember how to find inverses. When you have a matrix, a 2 by 2 matrix, as this one is, what you can do is you divide by the determinant, okay? So 1 over the determinant of that matrix, and then you do this. You swap these main diagonal elements. So this A is down here where the D was, and the D is up here where the A was. And then you just change the sign of these two. They were both no negatives in front. Now, guess what? They got negatives in front. So this is how you find the inverse. So in our particular case, we do that. We swap these two elements, and then we change the sign of these. without swapping them, and we divide by the determinant. And if we do that, we get this. Here's what we get. Okay, so there's the inverse. Well, now the job is to integrate. So look what we've got. We've got the fundamental matrix times the integral of this inverse times the f of t dt. Okay. Now, if we go through here and multiply this out, we get this. So you want to practice that. Be sure you know how to do that. This appears a 2 by 2, and this is a 2 by 1. Okay, so you're going to get a 2 by 1 matrix. Okay, which is what this is. And then you just integrate component by component. So I want to integrate this, and I'm using integration by parts or tabular integration. I want to integrate this, integration by parts, tabular, and I get this. Okay, here's what I have now. Okay, then I, work through this, clear my parentheses and everything, and I get this. And then I need to multiply this matrix by this matrix. And I get this matrix. That's a handsome matrix right there. Okay, so what we're doing is we've got a 2 by 2 here and a 2 by 1 here. So we're going to get out a 2 by 1. And sure enough, this is a 2 by 1. 2 rows, 1 column. Okay, and then here we go. When we simplify that whole thing, now look what we've got. Here's our general solution. We've got the fundamental matrix here, C1, C2. Okay, and then we've got this thing for the general solution. Now you could work with that and rewrite it all this way if you wanted to. Okay. But that's up to you. I'm not sure what you would prefer, but this is one way that you can write this solution. Okay. And that is your general solution. So you can see, quite a bit of algebra in here, but the concepts are simple.